Hello, and welcome to Graphing Logarithmic Functions, an intermediate algebra approach here. All right, so the fact is that logarithms and exponential functions are inverses of each other, and we saw that earlier in the definition of the logarithm, where y equals log base b of x is the same as, so it goes back and forth with b to the y equals x. So we know that logarithms, being just an exponent, are related to exponential functions, and it turns out they're inverses of each other. And so the graphs of inverse functions, as we know from inverses, are always symmetric across the line y equals x. That was the last thing I said in that particular video. So what we're going to do is we're going to graph each logarithmic function by first graphing its corresponding exponential function. All right, so let's get us a nice little grid. Let's start with the corresponding exponential function, base of 3, base of 3. Here's what I know, and we're going to take the three easiest values, -1, 0, and 1. 3 to the -1 is 1/3. 3 to the 0, anything other than 0 raised to the 0 power is 1. And 3 to the first is 3. Okay, so it looks like we need to get to 3. Let's label these here. It's -1, -2, -3. Same in the positive direction. Let's go up. That's my dog. I'm going to let her out. Hold on a minute. And we're back. All right. Sometimes dogs interrupt. That's the way it goes. I'm not like a one-hit wonder from the 80s or anything, but I'm definitely a one-take wonder. Very little editing in my videos. Okay, because that's what you get in the classroom too. You get mistakes, you get errors, you get random people screaming in the hallways. Let's keep it as authentic as we can. So in blue, y equals 3 to the x. If x is -1, my y value is 1/3. I'm just going to go close enough is good enough here. When x is 0, my y value is 1. And when x is 1, my y value is 3. Now, we talked about exponential functions already. So we could kind of throw up this graph. And, if you need to, make the point bigger. This does not go away from the y-axis. It gets closer to the y-axis, so that's a little mistake there. Now, in order to actually graph the logarithm, all we have to do, all an inverse does, is switch x and y. So now what was a y becomes an x. What was an x becomes a y. So I'll have y values of -1, 0, and 1. I'll have x values of 1/3, 1, and 3. So let's see. When x is 1/3, my y value is -1. X value of 1, y value 0. X value 3, y value 1. We could draw this in here very carefully. And I'm going to label this as our function. And that's how I draw a logarithmic graph every single time. Notice if we put the line y equals x in here, and we're going to assume I could draw a nice straight line. If I were to fold this over that dotted line, I'm going to call that pink, maroon. I don't know. Let's call it pink. The pink line would lay on top of the blue line. They're mirror images of each other. That's all it takes to graph a logarithmic function. So let's try again. All right, we'll set up our axes. We'll look at the related exponential function, base of 1/2. I'm going to use the easiest x values I can, -1, 0, and 1. So this is 1/2 to the -1 power. Remember that -1, that's a reciprocal. That flips it over. That becomes 2 to the 1, which is 2. 1/2 to the 0 power is 1, because anything other than 0 to the 0 is 1. And 1/2 to the first power is 1/2. All right, so it looks like we go up to 2's. Let's label this 1, 2. 1, 2 in all four directions. And then we put in our graph when x is -1, y value is 2. When x is 0, y value is 1. Interesting, that was exactly like the last one. When x value is 1, y value is 1/2. Now this graph is going to be decreasing from left to right, and it will continue to approach the y-axis. That's not true. The x-axis, the line y equals 0. Now that we have those points, we can graph the logarithmic function, because what was an x becomes a y. What was a y becomes an x. All right, just swap 1, 1/2 becomes 1/2, 1. And now we can plot the point 2, -1, the point 1, 0, and 1/2 is at 1. And then we will slowly be decreasing here as well. Oh, that wasn't so bad at all. And check it out. If we draw on this line, y equals x. I missed it. I almost got it. They should cross right on that line, but I missed it a little bit. Yeah, I was off by a little bit, but you get the idea. Notice, in our first example, 3 to the x is an increasing graph. Log base 3 to the x is also increasing. Always reading from left to right, it's going up. If our exponential function is decreasing, our blue graph decreasing, then our logarithmic graph will also be decreasing. All right, and those really, that's all we really have. So let's do 2 more examples just to make sure we understand. I'm going to slow scroll here, come back. Notice when the base was 3, I went out to 3's in every direction. When the base is 1/2, that 2 in the denominator, I went out to 2's in every direction. Now that we have a base of 5, I will want to go 5 in every direction. I want you to think about this now. Do you think that this graph will look like the first example, where the base was 3, or do you think this graph will look like the second example when the base was 1/2? All right, let's give it a shot. Y equals 5 to the x. That's a 5. Make sure it has a nice formal cap there. -1, 0, and 1. 5 to the -1 is 1/5. 5 to the 0 power is 1. I'm still just evaluating. 5 to the first power is 5. Notice it's reciprocal of the base, 1, and the base. So at -1 we have 1/5, super low, 0, 1, and 1, 5. Notice how this graph gets a lot steeper a lot more quickly than that base of 3. The higher the base is, the steeper this graph is going to be. We also have the logarithmic graph. Now that we have our points from our exponential function, what was an x becomes a y. In the same order, what was a y becomes an x. So at 1/5, I'll be down here at -1. At 1, we'll have a point of 0. And at 5, we'll have a height of 1. And we have our graph. Oh, I missed a point. If you ever miss a point on a graph, you just make it bigger. It's all good. Keep in mind that these lines do get, they keep going. There's an arrow at the end, but they never touch the y-axis. All right, that's some problems with my hand. My hand just isn't good enough to do that. Similar to how our exponential graphs never touch the x-axis. It's the same idea. It continues forever. It doesn't bounce back, as that kind of looks like right there. I really want to fix it, but it never touches the y-axis, but it gets super close all along. Last example. We'll do one more just to make sure. Here's a tip for those of you that are taking, that are my students. This question is going to be on the final exam. Being able to graph a logarithm, pretty important. And you'll notice I haven't even reached for the calculator, or until then, I haven't even pointed at the calculator. We don't need a calculator to graph these. Using the base of 1/4, I've gone 4 in every direction. Let's take a look. If y equals 1/4 to the x power, using the 3 easiest x values, -1, 0, and 1. -1 is the reciprocal. The reciprocal of 1/4 is 4. Any number other than 0 to the 0 power is 1. So when x is 0, 1/4 to 0 is 1. And 1/4 to the first power is 1/4. So -1/4. Notice this one looks a lot like our 1/2, only it's steeper. 1/4. We'll call it there. And our decreasing graph gets super close to the x-axis, but never actually touches it. We should put arrows on both ends. The actual function we want to graph, log base 1/4 of x. What was an x becomes a y. What was a y becomes an x. Same order, they still pair up together. So at 1/4, I'm at -1. At 1, I have a height of 0. And at 4, I have a height, oh, what? What did I do? At 4, I have a height of -1. Here's the problem, I can't read. 1/4 should be a height of 1, not -1. Sorry about that, there we go. So this decreasing graph should, again, its inverse, should also be a decreasing graph. Close enough is good enough. I missed that point. Let's make it bigger. Throw an arrow. And just for giggles here, there we go. I actually made it through the crossing point. So a logarithm and its inverse, an exponential function. Exponential functions are the easiest and quickest ways of graphing logarithmic functions by hand. If you were going to graph on a calculator, I would use, let me change that. I would use the change of base formula. I would say the natural log of x divided by the natural log of 0.25, right, 1/4. And when I create that graph, we'll just get this portion of it. If I were to set my window from -4 to 4, clickety, clickety, clicky, because I'm using my mouse. That's exactly what our graph is. Notice the fine mechanics of our calculator. The pixels can't get any smaller to show that this continues, but by hand, we can show that, and by knowledge, we know that. All right, that's it for graphing logarithmic functions. My students, definitely pay attention to this. Make sure you understand it. Ask questions if you don't. Thanks for listening.